In this video, we will be learning how to simplify radicals. And by a radical here, I'm specifically talking about square roots. Let's say we have this statement, square root of 16. Well, I hope you know that that is 4. That is, 4 times 4 is equal to 16. This statement here is called a radical expression. It's an expression that has our square root symbol in it. The number underneath this is called the radicand. That's the 16 in this case. Well, this symbol technically is the principal square root or the positive square root. That is, negative 4 times negative 4 is 16 as well, but when we use the square root symbol, we're just seeking the positive square root. So we say the square root of 16 is 4. Well, what if we needed some number that wasn't a perfect square, like say the square root of 8? Well, you could use your calculator and you could find that the square root of 8 is approximately 2.8 or so. But what we're going to learn how to do is to simplify this into the product of a number that you can take the square root of and one that you can't. So one helpful thing is to know what the first few perfect squares are. 2 squared is 4, 3 squared is 9, 4 squared is 16, so forth, 12 squared being 144. This list obviously isn't exhaustive. You could go on forever. But the numbers on the right side of this list we call the perfect squares. That is, their square root is a whole number. So you need to think, when you see this particular number, this radicand, you need to think, what are its factors that are perfect squares? For instance, 8 is 4 times 2. So you will rewrite this square root of 8 as the product of some perfect square and whatever the other number would be. We can rewrite a square root as the product of 2 square roots. The square root of 4 times the square root of 2 is the square root of 8. And this probably makes perfect sense to you. You just multiply the two radicands together. 4 times 2 is 8. Now we can take the square root of 4. What is the square root of 4? It's 2. So this becomes 2 times the square root of 2. The square root of 8 is 2 times the square root of 2. Just like we would say 3 over 6 is equal to 1 over 2, we have simply changed the way this statement looks. These two have exactly the same value. And this is the exact value of the square root of 8. It's not anything rounded. It is exactly what the square root of 8 is equal to. Let's take another one. Let's say we had the square root of 32. Well, what you want to do is think about the right side of this list. What perfect squares will go into 32? Perhaps you think 4, and you would be right. But you want the largest such number, 16. 16 times 2 is 32, so I will rewrite the square root of 32 as the square root of 16 times the square root of 2. Well, we can take the square root of 16, that's 4, so this becomes 4 times the square root of 2. And I will show using the calculator that those two are equivalent to each other. To my home screen, I'm going to evaluate the square root of 32, the second square root, 32. And you will see that's about 5.66. And now I will evaluate 4 times the square root of 2. Don't need that parentheses there. Enter. And you see they're exactly the same. Square root of 32 and 4 times the square root of 2 have the same decimal approximation. Alright, let's do a couple of more. Let's say the square root of 175. Well, you're thinking about numbers on this list that will go into 175, the factors of 175. Well, 25 will. 25 times 7 is 175, so I will change the square root of 175 into the square root of 25 times the square root of 7, because 7 times 25 is 175. Now I can take the square root of 25. What is that? 5. So this becomes 5 times the square root of 7. And I simply leave these two expressions connected. Connected means multiplied. All right. Let's say 27. The square root of 27. Well, 9. 9 is a factor of 27. So 27, the square root of 27 becomes the square root of 9 times the square root of 3. What is the square root of 9? It's 3. So this becomes 3 square roots of 3. I'm going to give you one, pause the video, and give it a shot. The square root of 12. Okay, you're thinking, what perfect square is a factor of 12? Well, the largest one will be 4. 12 can be written, the square root of 12 can be rewritten as the square root of 4 times the square root of 3. The square root of 4 is 2. So this is 2 times the square root of 3. We say 2 square roots of 3, or 2 times the square root of 3, or 2 root 3. You'll hear this statement said in a few different forms. It just simply means 2 times the square root of 3. One last example. The square root of 300. Okay, looking on our list, think, what perfect square is a factor of 300? Well, 100 is. 300 can be written as, the square root of 300 can be written as the square root of 100 times the square root of 3. Again, the product of a radical expression is simply the square root of 100 times the square root of 3 is the square root of 300. We simply multiply the underneath part, called the radicand. 3 times 100, 300. We preserve the square root symbol. Well, the square root of 100 is 10. We leave this square root of 3 as it is. These square roots, 2, 7, 3, we can't do anything with those. Those numbers are called irrational. The square root of these numbers are non-repeating, non-terminating decimals. All right, so the big idea here is whenever you're trying to simplify a radical expression, all you do is consider this radicand, that number underneath. You want to find which perfect square is a factor of that. Then write that number as a product of two square roots. One we can take the square root of, and one that we cannot. Then you take the square root of that number that you can take the square root of and leave it as a product of this other square root that you cannot.